Welcome to this explainer. Today we're going to explore how an ancient Chinese myth and a brilliant exiled prince solved a massive mathematical glitch that literally changed how the whole world tunes its instruments. It's this absolutely fascinating journey that connects ancient cosmology to the very music you listen to every single day. Okay, so let's actually start way back in 239 BCE with a myth. According to the ancient text, the Yellow Emperor's musician, a man named Ling Lan, was sent to the mountains to bring order to music. He cut bamboo pipes of specific lengths to match the singing of mythical phoenixes. By mimicking the 6 tones of the male phoenix and the 6 tones of the female phoenix, Ling Lan created the foundational 12 pitches of Chinese music.
To understand how this ancient legend connects to modern mathematics and global history, we're going to map out our journey through 4 main parts today. First, the magic numbers. Second, the universal tuning glitch. Third, a prince solved the math. And finally, East meets West.
Let's dive right into part 1, the magic numbers. You see, ancient Chinese theorists didn't just play music. They basically constructed a comprehensive musical universe. And they categorized this universe using 3 highly specific, almost magical numbers: 5, 8, and 12. These numbers dictated their scales, their instruments, and the absolute pitches they used to communicate with the cosmos. So take the number 5, for example. It represents the fundamental pentatonic scale. These notes, gong, sheng, zhu, zi, and yu, were directly connected by ancient theorists to the physical universe, specifically to the 5 phases of wood, fire, earth, metal, and water. They even linked them to the 5 colors and the 5 flavors. It created this profound web of analogies where music mirrored the exact structure of nature. Beyond those 5 notes, they looked at the physical materials creating the sound. They categorized all instruments into 8 sound materials, known as the 8 sounds or bai-in. We're talking stone chimes, silk string zithers, bamboo flutes, the whole shebang. Finally, all of these instruments were tuned to the 12 absolute pitches, the sheer lu. As we just learned, these were originally derived from the song of the mythical phoenix. And because music was used to accompany sacred rituals, hitting these exact 12 pitches was considered absolutely crucial for maintaining a harmonious relationship with heaven. Which brings us to part 2, the universal tuning glitch. Now, to actually generate these 12 pitches in reality, ancient theorists used a mathematical formula called the method of subtracting and adding thirds. It goes like this. You start with a bass pitch called the yellow bell. You subtract a third of the pipe's length to get a note a perfect fifth higher. Then you add a third of the length to go down a perfect fourth. It relies on a pure 3-to-2 mathematical ratio. But here's the catch. If you repeat this 12 times to complete your scale, you don't end up exactly where you started. You missed a clean octave by a tiny, extremely frustrating fraction. So here's the real question. What do you do when the math of music just doesn't add up? Think about it. What happens when adding and subtracting perfectly pure musical intervals completely ruins your ability to modulate smoothly between keys? If you try to shift a melody into a new key on instruments tuned this way, that tiny mathematical gap suddenly sounds incredibly harsh and dissonant. Well, it turns out this wasn't just a Chinese glitch, it was a universal human dilemma. In ancient Greece, this exact mathematical gap was recognized and named the Pythagorean coma. Meanwhile, over in ancient China, traditional music literature referred to this very same tuning problem as the Huangzhong cannot be restored. You have 2 vastly different cultures separated by thousands of miles, both staring down the exact same mathematical limitation in the physics of sound. Wild, right? And that leads us directly to part 3, a prince solves the math. Enter Zhu Zaiyu, a 16th century Ming Dynasty scholar prince. Now, his life was definitely not one of luxury. After his father angered the emperor and was imprisoned, Zhu ended up living out in the mountains. And there, he spent 30 years obsessively researching mathematics, astronomy, and acoustic theory. His resulting complex acoustic calculations, generated by left and right rotation, meticulously mapped out the generation of these problem pitches. Then in 1581, Zhu finally published the mathematical solution to the ancient glitch, 12-tone equal temperament. He realized that to make all the keys work together, you couldn't just use simple fractions. You actually had to distribute the imperfection equally across all the notes. He did this by dividing the octave logarithmically, taking the 12th root of 2. And guys, without a modern calculator, he managed to calculate this irrational number out to an astonishing 24 decimal places. But he didn't just write down the numbers. He proved them in the physical world. He built a remarkably precise 12-string tuning instrument, a monochord, alongside a set of 36 bamboo pitch pipes of varying lengths and diameters to completely physicalize his groundbreaking equation. He brought the math to life. When you look at the historical data, you really see this intense global race to find the exact correct ratio. Mathematicians and musicians worldwide were trying to solve the gap. Check out Vincenzo Galilei, who happens to be the father of the famous astronomer, getting super close in 1580. But look at Zhu Zaiyu in 1581. He hits the absolute mathematical bullseye of exactly 100 cents. Those are the tiny units used to measure pitch per semitone. And he did this entirely independently and earlier than the Flemish mathematician Simon Stevin, who published his own work in Europe just a few years later. Let's move to our final section, Part 4, East meets West.
This perfection of equal temperament fundamentally changed music forever. In the West, it gave classical keyboard instruments total harmonic freedom to modulate through all major and minor keys without sounding terribly harsh. It literally paved the way for the modern 88-key piano, tuned to the standard A40-40 pitch we use today. Meanwhile, earlier cultural exchanges along the Silk Road had already started blending musical traditions, bringing Persian and Indian string instruments eastward to beautifully integrate into Chinese ensembles.
And you can clearly see the profound influence of these Chinese aesthetics on Western classical masters over the centuries. I mean, ever since Marco Polo's travels, Europe was totally captivated by the East. In 1754, Gluck premiered Baroque satires in Chinese settings. By 1912, Mahler was setting ancient Chinese poetry to soaring symphonies. And in 1926, Giacomo Puccini literally utilized an authentic Chinese music box given to him by a diplomat to compose the pentatonic melodies of his incredibly famous opera, Turandot. The scope of this history is just truly staggering. When we look at the artifacts of human history, from the 7,000-year-old bone flutes discovered at the Hemidu culture site in China, all the way to the relentless mathematical calculations of an exiled Ming prince, we see a really profound truth. The universal human drive to find perfect harmony is deeply woven into our civilization. We've literally been trying to tune ourselves to the cosmos since the dawn of time.
Which leaves us with one final thought. If the exact mathematical tuning of the music you enjoy today is the result of thousands of years of searching, of linking mythical phoenixes to logarithmic equations just to solve a global glitch, what other universal secrets are hiding in your favorite playlist? Thank you for exploring this amazing explainer with me today. Keep asking questions and keep listening closely.